Hey, Physics 11 peeps. I just wanted to go through this lab rubric. I know that many of you will be writing your reports tomorrow and I won't be there. So I would like to tell you what I'm looking for so that when you write your report, you can do a great job. Okay, so 3 main sections. Lab design and data collection. This is kind of how you make your experiment. Data processing, this is basically your graphs and calculations, and then your conclusions that you take from your data. And then I put on a little communication section because it just should flow easily and be a good conveyance of what you found to the reader. Okay, so number 1, lab design, data collection. Title, you gotta have a descriptive title. So a scientific title is sometimes long and boring, but it helps the reader understand what you're doing. And if you're searching for something in an index or an online search, you can find it easily. The research question is basically what you're trying to find out. So I want something that's kind of relevant and specific to what you're doing. So for you guys with your acceleration lab, your research question might be something like, how does acceleration down a ramp vary with the angle of the ramp? Something like that. And try to make it specific, not just, acceleration. That's not good enough. If you're saying to investigate acceleration, that's probably not good enough. You want to kind of talk about your specific setup and what you want to find out about it. The background is something that I would love to see in your lab. It's not always required, but I think it's good in a senior lab to put that in. So, you might do a little paragraph or two, who discovered these things. Newton found these formulas and kind of go through how you could talk about the history of it, of how the acceleration of gravity was found, or just how it works, or go through a couple of formulas, or show a diagram. Just something that would help a younger reader to understand what your lab is about. Hypothesis is often misunderstood. It should be a statement that you're going to kind of hack on, try to cut apart, and you may disprove it. This is what you're testing and questioning. You don't want to say, we think this is going to happen. That's not testable. You don't want to say it's happening because of blah, 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 because you can't test that because part often. And so it's just a statement that you're going to test and be able to say, no, we couldn't disprove it and therefore it's supported, or we did disprove it and it's what we thought was wrong. So you just write the statement as if it was true. Okay. Methodology is the design of the experiment. So, it's not so, I kind of helped many of you with your design, and so that's fine. But basically, it's a great idea to have a little chart and list your independent variable, your dependent variable, and any variables that you have to control. Okay, so maybe you varied mass, but you dropped your cart from the same place on the ramp, and you kept your ramp at the same height, and you did the same cart in the same ramp, and all those kind of things. So you can do a chart of that if you like. It's a great idea. And then we get on to our graphs. So your raw data, basically want to see your raw data in there. Is it relevant data? You may have gotten this from Logger Pro, and so don't have to worry too much about your raw data. And then your graph is obviously a big one. Many of you will have Logger Pro graphs, but it doesn't have to be. It can be a hand-drawn graph too. And, the highest mark really is going to be for one that was curved and is linearized. And I talk about how to do that in another video. I kind of want to see that linearization. And so that these two sections here kind of go together. So did you get a relationship from your graph? Did you calculate this from a curved graph that has been linearized. And basically, I just want to see that you know how to graph the data and that you can pull a relationship out of that graph. The uncertainty bit is something you we'll start doing that this year, but for this lab, you don't need to do any uncertainties. If you can figure out how to do error bars and you have multiple samples, that would be great. But it's certainly not required in this lab. Conclusions, you want to have kind of a nice flow from your research question to your data to your conclusion. So does this all kind of fit together? Sometimes students get a little confused and their conclusion isn't necessarily linked to your data and your graphs and stuff. So we want that all to be linked together. I would love it if you're right in the beginning of your conclusion, you state the relationships. This is going to be the formula that you've pulled out of your graph. And it's awesome if you can clearly state that relationship and explain it. So what does this mean? So d equals 4t squared. What does that mean? Well, that means that every time you double the time, you're going to have 4 times the distance, right? There's something like that. So the better you can explain how that works in the real world and how you could use it to predict a situation, the better. You may verify this with an accepted theoretical value or formula. So it might be a number like 9.8 or a formula, F equals ma. If you're doing a verification lab like many of you are. And this might be complicated. If you're doing a ramp, you might have to do a little 2-dimensional work if you really want to do this well, because you're going to have to use some trigonometry and find out what the acceleration should have been down the ramp. If it's not exactly theoretical, that's fine. It's because the ramp has things like friction, and that adds to our interpretations and our errors. Errors are not mistakes. Don't say human error. When you do your inferences, your interpretations, and you talk about your error, this is error that is inherent in your experiment. So things like friction, human reaction time. Human reaction time is not a mistake. It's just inherent in your measurement. The error is usually not the smallest increment of the measuring system. If you measure it 4 times and you get, a centimeter of difference, well, that's not a millimeter, right? So you want to understand that error, and you can talk about it. You can talk about how to improve. If you give one good suggestion, and it's a thoughtful suggestion of how you might improve this the next time you do it, or how you could go on further and study the topic more, that's totally fine. And then I give a mark out of communication, just that to reward you for an organized lab report that's clearly understood and uses some scientific terms. Hopefully that's helpful. Try to get a draft done today. I'm not going to put a due date on it yet, but I think what I'll do is next week will be I'll want you to bring your lab reports in, and I will kind of go over them with you while you're starting the next activity. So maybe I will make that an assignment, and you guys can bring in your finished lab report. So work on it today and try to get it done, and then I'll make an assignment for kind of like a rough draft, and we can go through them and try to work on making a really good one. Okay, thanks guys. See you soon.